Hi everyone, this is the Sudoku web app team. I'm Sherry and I am a rising sophomore at the University of Maryland, and I'm majoring in computer science and minoring in cybersecurity. For this project, I worked on the solution verification and the solution algorithm.
Hello everyone, my name is Kevin and I'm a rising junior from University of Albany. I work in the board generation and user interface.
Our project was led by Eric Howe, our Code Labs mentor. Eric is a software engineer at Microsoft.
This app was deployed on GitHub. On the monitor, you can see a select box, which user can choose the difficulty. When they are ready, a new board should generate. User then pass in numbers onto the board, depending on their inputs. After clicking the Submit button, one of the three dialog will display.
For Sudoku Mechanics, as you can see on the board on your right, all the numbers on the board are from 1 to 9.
And to store these numbers, we use one-dimensional arrays.
Next, we have to make sure that we do not repeat numbers around the board, including the row.
To obtain each row, we took the board's index, divided by 9, and rounded to the largest number, but lower than the value before rounding.
Next, we have to also make sure that the numbers 1 to 9 also do not repeat for each column.
For the column, we calculated module 9 of the index.
And lastly, we have to also make sure that the numbers 1 through 9 do not repeat within each 3x3 subgrid.
The subgrid was calculated by adding two separate parts. First, we take the row index divided by 3 using integer division, and that result, multiply it by 3. Second, we take the column index and divide it by 3. Unlike the row index, we do not multiply again. Lastly, we add these two parts together.
One interesting part of the Sudoku problem is that it's NP complete. This means that a solution actually exists because it's not NP hard, which means that we do not have to approximate our solution algorithm. Next, it also means that the solution algorithm is solved in a non-deterministic polynomial time. We can then verify our solution in polynomial time.
The difficulty of a Sudoku puzzle is inversely related to number of clues or given numbers. In other words, a fewer number of clues results in a Sudoku puzzle with higher difficulty, as a player needs to consider more possible solutions for each box. The inverse applies to a Sudoku puzzle with more clues. To preserve integrity of a Sudoku puzzle, it must have only one solution. In the minimum number of clues a Sudoku puzzle can have to still be unique is 17 numbers.
Next, I'll be talking about the tech stack. When we chose our tech stack, we narrowed our choices to 3 choices: Angular, React, and Vue. Angular is a JavaScript-based open source and front-end web framework that is maintained by Google and also a community of individuals and corporations. React is an open source JavaScript library for building user interfaces as well. It is maintained by Facebook and a community of individual developers and companies. And lastly, Vue is a new and upcoming web framework that's developed and maintained by Evan Yu and a few of his core colleagues. For our project, we decided to use React, and this is for a few reasons. React, as I mentioned before, is maintained by Facebook, which is a fairly large company. And having a big company support this open source project, it means that our project won't have outdated code in the future. Next, React also has a flexible design structure rather than a rigid one. This means that we have more choices when it comes to deciding on how we want to go about implementation. The syntax for React is very similar to JavaScript, which means that due to our very limited time constraints, we would have a smoother learning curve, and we'd be able to get up to speed and start working on the project as fast as possible.
There are 3 different kinds of board. The first board holds a soft board that has been generated by 3 checkers. These checkers insert a number and see if it conflicts with other numbers in the row, column, and subgrid. The second board holds all possible values for each square, which is used in number and position generator. And lastly, the third board is made of an array of divs. These divs contain the value ID, another word for index of board, and input boxes. This array of divs is used for generating the user interface. The diagram you see was tweaked of a backtracking algorithm found in the website Code Project. This method helps fill out the board by telling what position it should go to. It gains help from another board called possible numbers, which keep track of what numbers each square can have.
And for the solution algorithm, I used a depth-first search approach. And the general idea of it is that first we have a stack that keeps track of all the empty squares on the board. We check if the stack is empty in a while loop. And then once we enter the while loop, we pop X from the stack and check if the possible values for the X is empty. If it's not empty, we fill the index of X with the smallest possible value. And after we do that, we pop X off the stack. And we check again if the stack is empty. If it's not, we pop the next one. And let's say for this time that the possible values for a square is empty. In this case, we have to backtrack until the possible values is not empty. And once the stack for the values to process is empty, we can stop. And at this point, either the board was unsolvable or we finished solving the board.
A default mode was used when user first came on the web. When the program runs, it generated the board, then removed the numbers from board, depending on what mode was set to. This simplified things since we do not need to check if the code was solvable at first. The submit button checks each number and see if it conflicts with other number or if there's a 0 on the board.
So for future improvements, while we didn't have, as we had a time constraint, we had limited time, we decided that we wanted to implement 4 things in the future. And those 4 things are first, improving the user interface by making it more friendly and changing the buttons so that they are different colors and possibly even changing the background of the Sudoku board. Next, we also wanted to implement a multiplayer functionality to make it so that a player could compete with someone else that isn't on the same computer. This could mean that we would be implementing some sort of timer feature so that users can compete with one another to see who can solve a board faster. Next, we also thought that our Sudoku game could be part of a larger game library with other games. And finally, we also considered adding a hint system where if a player was stuck, they could ask for a limited number of hints for the board.
Well, for me, the most enjoyable part was the board generation. It feels satisfying after the main component of the board was done. There were so many ways I can do the board. Well, because of that, we wasted a lot of time and scrapped the prototype of the board.
And for me, the most enjoyable part of our project was just learning the different tech stacks that I didn't know before, and also just researching the different mathematics behind Sudoku, because at first glance, it seems as if it's just putting random numbers on the board, but it was much more than that.
The hardest part was translating diagrams and other code languages to be compatible with our project. We could have gone back and relearned everything from high school years, but then for me, my previous project was wiped it, and I forgot to back it up. It was really no time to learn the basics, so I had to look into other games like tic-tac-toe, Minesweeper, Hangman, just to see how they all done their games.
And for me, the most challenging part was working in, it was my first time developing code in a team environment rather than an individual environment. So it took a little time for me to adjust to how workflow would work in GitHub because I'd never used it before.
Even though a lot was revealed, there was also a bunch I have learned. I understand what it is like to work at the same time with others using GitHub. I have never done pull requests, make new branches, or deploying with GitHub before. It was really different from using an IDE that multiple people can see and make changes in real time.
And for me, one thing I learned was definitely learning how to use Git. Like I said before, I'd never worked with someone else on a project before. So for me, it was learning the workflow and how pull requests work and how different Git commands would work. And that's all for our presentation. If you have any questions, you can find us at the different contact methods on the slide. For me, you can go to my LinkedIn and feel free to connect with me at the link. And for Kevin, feel free to email him if you have any more questions. Thanks.
Thanks.